Okay, everyone, we are live for the first course session of Discrete Maths 2. Welcome. For those of you who are sitting in V102 or you're sitting at home, welcome too. If you're sitting in V102, there's still room in V101. That's where I'm going to be physically. Otherwise, open your computers, follow the link, and watch the live broadcast. Okay, so as the title of this course suggests, this is kind of a continuation of, guess what? Discrete Maths 1. There's been a roar of an answer from your colleagues while others are streaming in. What my plan for today is to give you the standard, perhaps boring, but I think necessary introduction to the course. And then we get started slowly with the first topic in the course, which is a topic that as computer scientists you all know and love, namely recursion. The big R. Okay, so what is this course going to be about? Let me give you a little bit of motivation, even though you don't need any, do you? This is going to be a game of three halves. Well, not really. It's going to be a game of 3/3 because we are going to cover three different topics that I've been asked to convey to you in some form or another. So in some sense, you can think of this course as some kind of a Frankenstein type of thing. We're going to take things from three different fields and build a course out of it and then say, it's alive. Okay, so what are these three topics? The first part of the course is going to be devoted to an introduction to the basic theory of computation. In this part of the course, we will cover topics such as languages, grammars, and automata that are used to recognize languages that can be described using some types of grammars. Now you may wonder, why on earth are they going to expose us to this stuff? Well, there are good reasons for this. You're all in computer science because you like computation. Or even if you don't like it, you realize that knowing how computing works is actually going to be very useful for your future careers, whatever they might be. Now, since computation is our business, and these machines that actually carry out very complex computations for us are the things that we want to use, one of the things that we are always interested in knowing is what is it that we can actually do with these things? What is it that we can use to do efficiently? And what is it, if anything, that we cannot carry out using computers and the programs, the software that actually runs on them? This is absolutely fundamental as a type of knowledge because, well, whenever you have a tool, you want to know what you can do with it, but also what you cannot do with it. If somebody asks you to write a piece of software with a hammer, you're not going to do it because the hammer is not very good at doing that. At least, perhaps it isn't. Well, if somebody asks you to carry out to write a program to carry out some computational task, then perhaps that task is actually unachievable. And it's better for you to know that it cannot be done rather than just beavering away for years on end and get frustrated because you cannot do it. Perhaps the task that you've been asked to carry out is doable in principle, but not in practice. In that case, what is it that you do? You cheat in some way. Well, cheating, of course, in a formal sense, in the sense that you will end up actually approximating a solution, given that the perfect one is going to take longer than the life of the universe to actually achieve, even by means of this very fast object that we use every day. If you're given a programming language, you want to know, how is it that I can go about writing a compiler for it? How do I specify the syntax? That is to say, the correct programs that I can write in my language so that the compiler will actually not tell me all the time missing semicolon, missing this, missing that when I write a program. How do I specify the semantics of the programs in my favorite language? That is to say, what happens when the program that I've actually written runs on the machine? How do you do that? Well, automata, finite state machines or state machines of some kind, which you will meet in this course. And in fact, many of you have already met, I think, in the problem-solving course, play this role. And they are a really fundamental thing to know in computer science. That's for the first part of the course. If you don't need any motivation, by the way, tell me, because I know this stuff, or at least I'm passionate about it, even though I don't know it. The second part of the course has to do with a classic topic in mathematics that long predates computer science. Well, perhaps not. But it's called linear algebra. Okay, so basically in this course, I'm supposed to tell you everything you always wanted to know about linear algebra, but you never dared to ask. At least for those of you who are not taking linear algebra as a course at the same time. Now, why is linear algebra interesting for you computer scientists? Why is this piece of mathematics interesting for you? Have you ever wondered how Google Translate works? Do you ever use Google Translate? How many of you have ever done that? Yeah, most of us. Well, believe it or not, behind Google Translate, there is linear algebra inside. In fact, these days, Google are even translating not from one language to another, but from pictures to language. They have a tool that actually generates captions given a picture. And the caption describes what the picture is about. And surprisingly, this tool is already nearly as accurate as human taggers. How does this work? There's linear algebra inside. So it's not just computer graphics, which is linear algebra inside. It's not just coding theory, which is also linear algebra inside. It's not just error correction, which is also linear algebra inside. There is linear algebra in lots of applications in computer science. That's the reason why the second part of the course is here. After having followed a third of this course on linear algebra, you will at least know the basics. And then perhaps some of you will go on and explore the whole world of linear algebra. And you will know, for instance, why Google PageRank actually can rank the goodness of websites according to your searches so well. Because even there's linear algebra inside. Well hidden, but it's there. And it's the thing that makes everything work. The third part is something that you have already started seeing in Discrete Maths 1, namely the theory of probability. How likely is it that when I throw a die, I get a 6? The answer is 1/6. Yeah, good, excellent. Well, that's just the beginning. What we are going to do in this course is a little bit slightly more advanced. And the reason why you're supposed to look at probability is because probability is also everywhere in computing these days. I mentioned before that certain algorithmic tasks may be very hard to carry out, even using very fast machines. However, computer scientists have discovered that somehow you can get fast, efficient algorithms for carrying out sometimes very complicated tasks by using the power of randomness. Typically, when you think about the program, you think about the thing that acts deterministically. You don't want your program to process the same input and one day it gives you 1/3 as an answer, the day after or three minutes later it gives you a half. If it starts doing that, you think, wow, this thing is alive. It looks like me when I carry out computations, which is not what you want. You want it to be precise. Well, however, randomized computation actually sometimes decide what to do next by tossing coins or throwing a die. Deciding, okay, so that if I don't know what to do, I toss a coin. If I get ahead, I go and proceed by doing this thing. Otherwise, I do this other thing. This may seem useless, and in fact, it isn't. It is very, very useful, and it can produce very efficient algorithms. Is this the only use for probability theory? No way. Have you ever heard about machine learning? Learning theory? Well, computers actually can learn today, to the point that you have Watson that actually beats and thrashes all the best humans at Jeopardy. Behind all that, there is a lot of machine learning, data mining, and a lot of algorithms that actually rely on probability. Because make no mistake, machine learning looks like probability theory. That's what it is in disguise, statistics in disguise. And in fact, how do we learn? By experience, yes, but what is our experience? Nothing but perhaps a huge probability space where we try different things, we perform random simulations of what happens in our real lives if we do this or that. Am I going to bring flowers to my wife or my girlfriend today, or do I wait until tomorrow? Well, it may change your life. If you wait until tomorrow, perhaps she leaves you today. And then, well, your life may be better or worse depending on how it develops. Well, it's all probability, you see. So are you motivated? Yeah, that's why we are here. Apart from getting the pass for this course in your case. But that's not important. What matters is the concepts that we are going to learn in this course. And I say we because I'm going to learn them, hopefully, together with you. You're probably going to learn them faster. Now, what kind of concepts are we going to learn specifically in this course? What kind of skills are you going to have? Well, there is one official document for this. It's in my school, on the My School page for the course, and it's called the Learning Outcomes. We are supposed by all kinds of authorities to give you a very detailed list of the things that you're supposed to know and you're supposed to be able to do at the end of the course. This may seem boring, and make no mistake, for me, it's boring, but it describes precisely the contract that we have between the two of us, between me and you guys and gals. If tomorrow you want to know, do I deserve to pass this course? Am I ready to go to the exam and pass with flying colors, which is your aim? Then all you need to do is to go through this list of things that you're supposed to be able to do and ask yourself, can I do this? If the answer is yes, tick, move on to the next one. If you can answer yes truthfully to all of these, I should be able to do this, then you're ready. The exam is going to be a piece of cake. Okay, so this is our contract. And in fact, my inspiration is what a guy called Biggs called constructive alignment, which is precisely this. I'm going to examine you exactly on the things that are written there and no other. That is to say, if you can tick those, there are going to be no surprises. Sigh of relief. They are laughing, so sigh of relief. Okay? That's a contract. You know what you're supposed to do? I hopefully know what I'm supposed to be doing, namely to try and help you master this material. Note, I didn't say to teach you this material. I said to help you master this material. Why? Because you learn. I can only try to help you by giving the best possible explanation I can of the material, and by giving you the exercises that will help you learn it. But you're doing the job. I'm not delusional to think that I'm going to cram stuff into your heads. You do. And you don't have to cram stuff into your heads. You have to understand what we are doing. And then everything else is easy. Of course, there are things like a textbook. I've already answered 2 or 3 million emails related what kind of version of the textbook you can use. Basically, anything goes. Anything goes. Well, provided it's some version of this textbook and it's not version 1 that is probably was used in the Paleolithic age. Okay, for some other parts of the course, namely linear algebra, which is not covered in this book, I will give you photocopies from some other book. So you don't need to buy anything else. In fact, most of you already have a version of this book from Discrete Maths 1, so you don't have to buy anything. Good, because I know how expensive the books are there. I'm also responsible for one of those, and I apologize. Okay, there will be lectures. Surprise, surprise. However, the lectures are going to be more like table tennis. It's not just like I speak like I'm doing now, which I'm known to like and do, but I don't plan to speak all the time. We are going to play intellectual table tennis, which means that I will pepper you with questions. You give me answers, you ask me questions, and we will play table tennis together with the goal to become good at table tennis. Well, intellectual table tennis related to this course material. Every question is good, so ask questions. Be active both here on Piazza and actually answer each other's questions. Because by actually formulating good questions and answering questions from your colleagues, you will understand the material better. If you can explain your knowledge to someone else, and this could be the person sitting next to you in the room or on Piazza, then that's when you really feel that you understand something. Sometimes you hear people say, oh, I really know it, but I can't explain it. Have you ever heard this? I'm sure you have. Well, the truth of the matter is that when I say that, I really don't understand what I'm talking about. Because if you know it, you can explain it. If I know something, I can explain more or less well, but I can. So try to explain to one another. Learning takes place also when you discuss with one another, so behave as a group of peers who actually teach each other. When I was a student, I learned sometimes much more by talking to my colleagues than by listening to people like me now, not 20 plus years ago. I'll put the slides before every lecture. Okay, so I hope you will forgive me. Sometimes I forget, but I'll try to do that. And do read the literature. You know, the reason why we have a textbook is not because it costs a lot of money and the author makes some money. The reason why we suggest it is because it contains useful material for the course. So even though the lectures are going to be fantastic, well, I hope, good at least, or not too lousy, even though the lectures are something that are going to give you something, the real learning takes place when you actually sweat on the material, read over, produce your own notes, and think about it. The books actually, and the suggested reading, contains worked out examples, exercises, and all the other stuff. At the end of the day, what's the point in having a book if you never read it? Of course, you can sell it for nearly the original price because it's basically new. But on the other hand, it didn't help you very much during the course. Important. I told you already that I believe that you learn when you work. You learned something in the classroom, but the actual learning takes place when you sweat on the material. And when does this happen? Of course, it happens a little bit in the lecture room because we are going to work through examples together during the lectures. You're also discussing with one another, and that's also work. However, you want to put what you learn into practice, and this happens in the exercise sessions. How are the exercise sessions going to be scheduled, and how are they going to take place? In this course, and now don't get scared, in the exercise sessions, you do the exercises. The TAs are going to help you do the exercises. So what does this mean? That you will work on the exercises, and when you're in trouble, you ask the TA for assistance. I encourage you to work in groups, to work together. Why? Because I think that you learn from one another. In fact, many of the assignments will be, you can deliver in groups of 2. There are several reasons for that. It's more fun, you learn more, and you're less tempted to plagiarize. You've already heard this nasty P word. It doesn't have a place anywhere. You're here not because you want to get 4.75 at this exam, at the next one. I mean, this is like failing, really. You're here because you want to be as good as computer scientist as you can possibly become. Why? Because afterwards, you're going to get a great job, whatever that may be. And you know who are the people who get the great jobs? The people who can think independently, solve problems creatively, and know something or can think like others cannot. Well, is this an innate skill? Partly, but most of it is work. Genius is 10% inspiration and 90% perspiration. Edison used to say that. And he was right. Believe it or not, even the smartest people on earth work. And that's how they get lucky, because luck favors the prepared mind. Okay? So this is going to be like problem solving, essentially. You work together in groups, people help you. And in fact, I encourage you to work on the home assignments during the exercise sessions. Why? What are the advantages? Well, first, you don't have to do it later at home when you're alone. You can do it together with your other guys, with your other group, with the other people you work with. And second, you get the assistance of the TAs. Why? Because the home assignments are there to help you learn the material. They don't weigh very much, but they prepare you for the exam. Are you happy with this, or are there any complaints? You know, the motto in this course is the motto of the samurai. The more you sweat in training, the less you bleed in battle. Exercise sessions are the training, as well as the other times when you work together. The battle is the final exam. Okay? Excellent. And use the course discussion on Piazza. Ask good questions and answer questions from your colleagues. I will try to answer myself. The TAs, when they will become available, will answer questions. I have to tell you, last year I got completely carried away. I mean, Piazza was my wife, and this was way too much. I had an average response time of 13 minutes on Piazza, including nights, and I didn't have a life. That was a bit too much. I will do my best, but I don't promise I can do anything like that again. Probably I will not survive until the end of the course. So it's easy to get carried away when you have this online. I mean, this is like Facebook and all these social networking things. The only thing is that for a good cause. Important thing, you can post anonymously on Piazza. So if you don't want your name to appear on whatever post for whatever reason, you can do that. However, as you probably know, anonymity gives people a lot of power. Sometimes you would post stuff anonymously on a website that you would never dare to say if your name was on it. There is no place in this course or any course, or in fact, there is no place on the net for any behavior of that type. You have to treat everyone else in this course with courtesy. They are your friends, your peers. And actually, this also includes the teaching assistants and me, because we are in it together. I'm not your enemy, I hope. I'm your friend. And I view you as my friends in this course. We have a common goal, learning stuff as passionate computer scientists. So there are many ways of saying the same thing. If you can avoid offending people, please do. Do you agree? I'm sure you've never seen anonymous, nasty comments on any of the websites that you normally use. Oh, by the way, sometimes people ask me, what is a good question? And of course, good question is in quotes there. Well, a good question is one that will be labeled as good by me on Piazza. But in general, there are many ways of posing a question. A good question is one that helps whoever needs to answer the question to give the most appropriate answer. For instance, if you're trying to solve an exercise, sometimes, perhaps doesn't happen to you, never, but sometimes people come to me and say, I don't know how to start this exercise. Has this ever happened to you? Well, typically, when such a question comes, which is not really a question, it's a statement, I don't know how to start. There is no question mark at the end. The I don't know how to start typically arises from two situations. First of all, people have not read the statement of the exercise. So if you don't read what they're supposed to do, then it's a bit difficult to know how to start because you don't know what you're supposed to do. Okay? Second thing, you actually read what you're supposed to do, but you don't understand it. And here there are typically two possibilities. One of them is that you don't understand the technical terms in the question. What does this mean, according to you? Typically, this means you haven't read or you haven't followed the material up to that point. So what is the obvious thing to do? To actually read the stuff related to the exercise before you actually try to solve it. It's like some box comes from IKEA and I haven't read how to put it together, still I try. The result is not going to be particularly good. And certainly it's not going to be a wardrobe if it was supposed to be a wardrobe. It might be a washing machine or whatever else, which is something you want to avoid. So, but if you actually have read the question and you know the meaning of the basic technical terms, then you can certainly sort of get up to a certain point, and at that point you get stuck. So what you can ask when you actually ask for help is to describe what is it that you know, how far you've got, and what your problem is. At that point, we can answer giving you the most appropriate answer. Oh, why don't you try this next? And at that point, the hurdle is over. Do you agree? Is this the right way to proceed? I see a lot of blank faces here. So I know I'm telling you stuff that you already know, but you know, I mean, as the Latins used to say, repetita juvent, I'm just telling myself how I should go about doing things. And perhaps this can help you too. Fantastic. I've already told you about the assignments. I mean, the assignments, you find all this stuff on the website. Remember, there is no room for plagiarism. Always deliver your own work. And in fact, as I've told you, in many assignments, you can deliver in groups of 2. But, important, make sure that you understand what you deliver. There is no point, there is no gain in delivering with someone else who did all the work. And you just produce the coffee, perhaps, to sustain the effort of the other person. In that case, well, perhaps you can make very good coffee, but it's not going to help you very much in passing the course or in understanding the course material. And the reason why I want you to work independently and to take responsibility is because if you do that, the final exam is not an exam. It's a celebration of your own learning. If you can tick all the, I should be able to do this on the learning outcomes, if you do the work, the exam is piece of cake. Because you know the stuff in the course. Even though I'm only supposed to get 4.75, which for me is a fail, but if to pass the course, it's not going to be of your concern because you will all get 8 or above. You can all do it just by working. And for those who pass and have shown some activity on Piazza, they can get a bonus if necessary, so that you can get 10 plus plus or whatever for the course. Any question? Oh, before you ask the question, policy, no late delivery. Now you can say, this guy's a bastard. No. you will get at least 1 week for each one of the assignments. You can work on them during the exercise sessions. The reason why I don't allow late delivery is that it's a good idea to get used, also for your future work, to deliver on time. It's something that computer scientists, including me, are not very good at doing. We always ask for deadline extensions. You will be surprised how many of your teachers actually ask for deadline extensions when they need to deliver a paper for a conference. But we know it's not good. That's why we don't want you to do it. Actually, I never ask for deadline extensions. Now, Pinocchio's nose is not visible on Google Hangout. Okay, so preaching. The first half of today is just going on preaching, but I think it's important. Do we all agree what we are up to? Confucius, I hear and I forget. I see and I remember. I do and I understand. He was an expert in pedagogical theory a long time ago, and he was right. In fact, in my case, instead of I see and I remember, is I write and I remember. I tend to remember much better the things that I write rather than those that I just see. But certainly, if you actually work with the material that we cover, you will understand. And once you understand it, you're in business. Are we ready? Fantastic. So we're ready to start. Okay? So any questions about the boring preaching part? Any doubts? Yes.
The two assignments, the test assignments, are they a test or assignment?
Okay, the question is, and if I forget to repeat the question for those who are live, please spank me, metaphorically speaking. Metaphorically speaking. The question is, are the two test assignments, are they tests or are they assignments? They are just ordinary take-home assignments that weigh 5% of the course. The reason why I call them test assignments is that they're going to be slightly longer and they will help you figure out whether you understand the material in a certain part of the course. So you will be able to tick some of these learning outcomes after doing the test assignments. The other ones are going to be shorter, they weigh less, and probably the test assignments are best delivered alone. But I mean, I'll think about it. Another question, yes? The course participation, whether that means online or here. Well, I'm not going to take names of people who come in here. You're far too many for those. I hope to see a large room throughout the semester. But I'm not going to get names of all of those who are here. But the class participation is, the only thing I can see directly is participation online. Note, only the good questions count. So if you ask, when is the next lecture? Or what's your name? Or any question of that type, it's not going to count towards your course participation. But if you ask a good question or answer well a question from one of your colleagues, I will endorse it and you get credit for that at the end of the course. Okay? Course participation. Thank you for the question, by the way. Course participation. You know, there is a tendency to believe that what you watch on YouTube is exactly like what you experience live. It isn't. Not just because, I mean, you can certainly live without looking at me. I'm not Brad Pitt or whatever. But on the other hand, the experience of being here, I think, is useful. Why? Because you can ask questions live. You can get the feeling of what it means to understand the material. Okay, some people, they could learn this on the moon or on Mars or on Pluto. They can do whatever they like. But for most human beings, for most of us who have ordinary capabilities, including me, it's a good idea to feel that you're part of this course as you develop. So I hope to see you in large numbers throughout the semester. And these large numbers, let's see what they mean later on. Any more questions? Yes. Okay, the question is, when are the endings on each day? I posted a message yesterday with the tentative dates. It's on the My School webpage. Which prompts me to point out one thing. I know you all get a lot of emails. You have a lot of messages to read. But part of your duty is to read the course-related and the message-related and the course-related messages for this course or any course. Make no mistake, no matter how many emails you get, I get 100 more, times more. And I'm supposed to answer. I promise that I will answer. So far I have. Let's see how long I last. But you should read the course announcements. Okay? And this, if there's anything missing, you tell me. I'll try to correct that. Whatever the problem for the course, whatever problem you might have, come to me. Because I'm where the buck stops. I'm the one who can do something about it straight away. And I don't hold grudges. So I'm approachable, I like to think. In any event, you can post anonymously on Piazza. But don't flamethrow, please, because I'm a human being too, and I get burned. Okay? Fantastic. Now, we take a break. I think, so normally we take 10 minutes break. Today, since I've actually only been able to tell you things that you already know and they have absolutely no mental content, we take a 5-minute break. Normally it would be 10 minutes because 5 minutes is too little. Okay?